Just days ago, the Earth roared to life in one of its most remote and violent corners. A massive magnitude 8.2 earthquake ripped through the crust off the coast of Russia's Kamchatka Peninsula, releasing the energy of thousands of atomic bombs in a matter of minutes. For the few hardy souls who lived there, it was a terrifying event. For the rest of the world, it might have felt like a distant, disconnected piece of news, but it wasn't. That quake was a message, a powerful tremor sent through the vast, interconnected system that governs our planet. And that message was heard loud and clear all the way across the Pacific, right here at home. So we have to ask the critical question, was this a random, isolated event, or is it a sign that the Pacific Ring of Fire is awakening in 2025? First, let's get our bearings, because understanding this story means understanding the place it began. Where exactly is Kamchatka? If you look at a globe, find Alaska. Now trace your finger west across the cold gray waters of the Bering Sea. That giant 800-mile-long peninsula hanging off the edge of Siberia, pointing down towards Japan like a stony finger. That's Kamchatka. It's a land of almost mythical extremes. Think of it as Alaska's angrier, more explosive twin. It is, without exaggeration, one of the most geologically active places on the entire planet. Home to over 160 volcanoes, with nearly 30 of them actively steaming, erupting, and sculpting the landscape. It's a primordial world that is constantly being torn apart and rebuilt by raw geological power. Brown bears here outnumber people in many areas, and the landscape is a raw mix of acid green crater lakes, steaming geysers, and vast empty tundra. During the Cold War, it was a sealed-off military zone, completely hidden from the Western world. Today, it remains one of the planet's last great wildernesses. More importantly, it sits right on the corner of one of the most volatile intersections of the Ring of Fire, where the immense Pacific Plate is being shoved violently underneath the North American plate at a rate of about 3 inches per year, roughly the speed your fingernails grow. It's a place built for giant earthquakes. So, a huge quake happened in a place known for huge quakes. Why is this time different? The big deal is that no major earthquake is an isolated event. We tend to think of the Ring of Fire as a string of separate Christmas lights. If one bulb blows, the others are fine. But that's not how it works. A much better analogy is to think of it as a single, enormous pane of glass that's already riddled with cracks. When you put immense pressure on one corner and it finally shatters, stress lines and vibrations shoot across the entire pane, weakening other cracks and creating new ones. The Kamchatka quake didn't just shake Siberia, it fundamentally changed the stress field across thousands of miles of the Pacific Plate. In seismology, this is known as Coulomb Stress Transfer, and it's a fascinating and frankly terrifying concept. Picture a line of very heavy books all leaning on each other on a shelf. They're stable for now, held in a delicate balance. The earthquake is like yanking one of the books out of the line. What happens? The book that was leaning on it now has nothing to support it, and it slams down. The book on the other side suddenly has all the weight shifted onto it, pushing it closer to its own tipping point. This is exactly what happens with faults. The rupture in Kamchatka instantly relieved stress in that one spot, but it's like squeezing a balloon. The pressure has to go somewhere. That energy is transferred to neighboring faults, loading them with extra stress and potentially pushing them closer to failure. The Kamchatka quake created what's called a stress shadow in some areas, making them safer, but it also cast a stress spotlight on others, making them far more dangerous. And this is where it gets personal for those of us in the United States. That same boundary, that same line of geologic tension that ruptured so violently in Kamchatka, is not a local Russian problem. It is our problem too. That fault line continues eastward, forming the volcanic chain of the Aleutian Islands in Alaska. It then curves south, becoming the infamous Cascadia Subduction Zone off the coast of Washington, Oregon, and Northern California, and further south it transforms into the San Andreas fault system that slices through California. It is all one, massive, interconnected system. A jolt on one end of the chain is inevitably felt all the way down the line. Let's focus on the Aleutian Islands for a moment. This string of islands is the most direct physical bridge between the Kamchatka event and North America. The stress from the quake is traveling along this chain like a lit fuse, and seismologists are watching it with extreme attention. But the biggest concern lies just south of there, Cascadia. The Cascadia Subduction Zone is eerily quiet. Too quiet. It hasn't had a major rupture since the year 1700, and it is currently locked tight, building up over 300 years of strain. It is primed for its own magnitude 9 event. So when a neighboring fault system just up the road has a catastrophic failure, it's like a giant next door slamming their door so hard it shakes the foundation of your own house. The additional stress loaded onto the Cascadia locked zone could be a significant factor in its future. Further south, the San Andreas fault is a different kind of beast, a strike-slip fault where plates slide past each other horizontally. But it's still intimately connected. The entire Pacific plate is a single semi-rigid body. A multi-meter shift off the coast of Russia nudges the whole thing, altering the complex forces that hold the San Andreas in check. Modern science doesn't have to guess about this, we can now visualize it. Using incredibly sophisticated supercomputer models, essentially digital twins of the Earth ES crust, geologists can simulate the Kamchatka quake and watch the stress transfer happen in near real time. They feed these virtual fault laboratories with data from thousands of seismic sensors and high-precision GPS stations that can detect millimeters of movement in the ground. They even use radar data from satellites, a technique called INSAR, to build 3D maps of how the Earth's surface has deformed. All of this information allows them to see which specific fault segments have been loaded with stress, turning scientific theory into a terrifyingly practical map of risk. So, let's go back to the big question. Is the Ring of Fire truly awakening? Geologically speaking, of course, it never sleeps. But it does seem to go through phases. History is filled with examples of seismic sequences, where one big quake seems to trigger a cascade of others. In the 20th century, a series of 7 major earthquakes progressively ruptured along the North Anatolian Fault in Turkey, each one seemingly triggering the next one down the line. What scientists are concerned about now is whether this huge event in Kamchatka could be the kickoff for a new global period of heightened activity. Is it the first major domino to fall in a chain reaction that could cascade around the Pacific? The honest answer is, we don't know for sure. Prediction is still beyond our grasp. But we would be foolish to ignore the warning. This earthquake wasn't just a news headline from a faraway land. It was a physical and measurable reminder that the ground beneath our feet is not static, and no part of the system is truly isolated. For those living anywhere on the West Coast, this is a profound wake-up call. It's the planet reminding us that preparedness isn't a suggestion. It's a fundamental necessity of living on a geologically active world. The Kamchatka quake was not an end. It was the beginning of a new chapter in the ongoing story of our planet's evolution. It sent a shockwave around the world, and now scientists, and all of us, are waiting and watching to see where the echoes will be felt the most.